anam, hayalap sağınap yakkan anam, dört bölüp tün uykusun aksıp bir gün, umuttan sonu kaydı bal.
Here on this vast hot plain on the edge of the Gobi Desert in western China, in the shadow of the beautiful snow-capped Tian Shan mountain range, thousands of people have come to witness a truly spectacular natural event, the total solar eclipse of the sun. It's August 1st, 2008. I'm Rob Semper from the Exploratorium, and for the next hour, the Exploratorium and NASA are going to bring you the sights and sounds of this total eclipse from here near Yiwu in China, in Xinjiang, China. We're going to show you some talk about the eclipse. We're going to talk about sun physics, the location that we're at, and we're going to show you, most importantly, beautiful images of the sun as we go into the total eclipse. Thousands of people have come here from all over the world to this spot on the Silk Road to view this wonderful event. And that's because this is not a normal event. Some of you may have seen a partial eclipse of the sun or a lunar eclipse. This is something special and much more dramatic. In about 30 minutes from now, it's going to change here dramatically. The light is going to fade, the temperature is going to drop, and at totality, when the moon passes in front of the sun, this blue sky above us is going to disappear. We're going to see the stars, the corona, and where the sun was, we're actually going to see a hole in the sky that's going to be an amazing, amazing experience. In a few minutes, you're going to meet Dr. Eric Christian, NASA scientist, who's going to talk about sun physics. You're going to meet Wendy Xu, who's from Xinjiang Television, to talk about the location that we're at. But first, I want to introduce Paul Doherty, my co-host for the event, senior scientist at the Exploratorium. And Paul, this is really exciting to be out here, isn't it?
This is a fantastic place to watch a total solar eclipse, Rob.
You've been to a number of them. How many has it been now?
7 I've seen, and this will be the 8th, and it's looking good.
Looking good today, that's right. We're a little worried because of the cloud cover, but it looks like it's broken through, so we plan to bring you a great eclipse today. Well, you know, the eclipse actually started here. It may not look like much is happening out here, but the eclipse actually started here about 20 minutes ago. And why don't we just go right to our telescope view and see what's happening in space?
So when we look at the sun using eye protection, and we are on our camera as well, we see a large bite taken out of the sun. Now that bite is the disk of the moon moving across the sun from the bottom right of the image towards the upper left. We're going to watch that progress during the whole course of the event. Now, this may look like a children's view of the phases of the moon, but of course, these are not the phases of the sun. It is the moon moving between the Earth and the sun. And we're just going to watch that during the entire eclipse event.
This is going to take a while, isn't it, to occur?
That's right. From the moment that the moon's disk occults part of the sun, it's going to take about an hour to reach totality. And then after the total solar eclipse, after totality, it'll be another hour till the whole event is over.
This might be a good time to talk about what an eclipse is, Paul.
So we have an animation which will show us what an eclipse is. So in this animation, which is running at very high speed, the moon moves in front of the sun. When the photosphere of the sun, the bright part of the sun, is completely blocked, there's that flash you saw here, which was the corona reaching out into space, and then the moon moves on, revealing the sun again. We'll run that through again. So here comes in the moon. In fact, this orientation is about exactly what we're seeing here in the plains above Yiwu, China. So there it is, moving across during totality. When the photosphere is blocked, our eyes adapt and we can see the corona. Now, of course, this is running at extremely high speed, playing back in a few seconds, which is going to take 2 hours.
That's kind of amazing about the eclipse because it has a lot to do with a certain size of the moon and a certain size of the sun and distance, doesn't it?
That's right. So the moon is 100 moon diameters away from the Earth, and the sun is 100 sun diameters away from the Earth. And so even though the moon is much smaller than the sun, because it's exactly the right distance away from the Earth, it can block the entire sun. So I have an experiment for all of you to do. You can take your thumb, which, like my thumb, is smaller than Rob's face, and if I move my thumb close enough with one eye, I can block Rob's entire face, a total eclipse of the Rob.
Thanks a lot, Paul.
With his hair as the corona. Now, this is an extremely unlikely coincidence that the moon's exactly the right size to block the sun. Now, we have an image from the Stereo B spacecraft, which is 4 times further from the moon than the Earth is. And it caught the moon moving across the sun. And let's take a look. So here it is. Look at the disk of the moon. And because the Stereo spacecraft is 4 times further from the moon is 1/4 the size as it appears from Earth. And that little moon just doesn't block the entire sun at all. Now, as the moon does block the entire sun on the Earth, it casts a shadow on the Earth. And we have another animation that will show you that shadow. So here, looking down on the Earth from the Mir spacecraft in 1999, we see the central dark shadow where totality occurs. Today, that'll be about 30 miles across. And then a much larger dimness on the Earth. And today, that'll be 4,000 miles across. And of course, it's moving at 1,000 miles an hour towards us across the surface of the Earth.
Well, let's go back up to our telescopes and see what it looks like out there.
So, you know, this moon is moving across the sun, obscuring more and more of it slowly, like watching the minute hand move. But boy, that's an amazing image. Oh, they've just moved, the telescopes to the upper left part of the sun, and there we see some solar prominences. Using our filters on our telescopes. These are hot gases from the sun moving out from the sun. These prominences are bigger than the Earth. They're higher than the diameter of the Earth, maybe a couple times higher. So we're going to be in for a treat looking at the sun today.
So we're about 32 minutes before totality, and I thought we'd spend time a little bit talking about the light. The light out here looks about the same, even though the eclipse started about 20-25 minutes ago. That's because our eyes are sort of adapting, and so we don't really see the drop in brightness. So I brought a light meter with me to actually measure the light as it changes. When I saw an eclipse in Turkey 2 years ago, I noticed the light dramatically changed towards the end of the time before we got to totality. This light meter is reading the lightness out here. It's actually reading about maybe about 2,000 foot candles. A foot candle is the amount of light that a candle gives off 1 foot away. So 2,000 foot candles is pretty bright, and we can certainly feel it out here. It's really hot out, by the way. And in fact, Paul, I think you've got a device with you as well.
Well, in my past eclipse experiences, it's felt very cold during totality. So I brought a recording thermometer with me so we can watch what happens to the temperature. So it's reading right now, the probe was in the sun, but it's reading 101.7 degrees. It's hot out here in the desert. But we're going to see how much it cools off as we pass through totality. This is a recording thermometer.
So actually, it's probably a good time to realize that this eclipse is going to happen about 25 or 30 minutes from now. But actually, some people on Earth are actually seeing this eclipse right now. That's because there's a path of totality. Let's talk a little bit about that.
So we have an image showing the path of totality here, that this shadow of the moon touches the Earth in Canada, near Aleut, Canada, at sunrise. So there, the sun rises totally eclipsed. And then it moves at over 1,000 miles an hour across Greenland, across Russia, across Mongolia, into China, passing over us. And then it continues on and is fully eclipsed at sunset in the eastern part of China.
So, of course, we had to be on the path or we couldn't actually see the eclipse. And the path is only about 30 miles wide for this eclipse.
And several thousand miles long.
It's very long. But there's another reason why we came here, and that's because of the weather. Of course, you can't see an eclipse if it's cloudy. And along the path, it was predicted that this location would have the best weather at this time of year. It turns out to be true. As I said, we're a little bit worried about the clouds, and you may see a few clouds passing in front of the sun, in fact, in some of our telescope images. But the weather is probably ideal, and I think we're going to be in for a really spectacular eclipse at this location.
We also have an animation showing the shadow on the Earth moving across the Earth. So if you want to run that, here it is. So the Earth is rotating, and the moon is orbiting, and the combination of the motion of the moon and the motion of the Earth produces this track, the path of the shadow, that brings us this total solar eclipse. And you know, there are lots of people that live in that path, and they're the lucky ones. And there are people that live near it that can travel short distances. Of course, we traveled halfway across the Earth because we know it's worth it to see a total solar eclipse with your naked eyes.
Well, let's go back and check the telescope view to make sure we see what's happening in space. You can see the sun is encroached, the moon is encroached a little bit more across the sun. It's kind of a gradual movement, but it's slowly eating up the sun. And this location here, the reason so many people came here is partially because of the weather, but it's actually very hard to get here. We're about 8 hours from any airport. People have been coming all night by bus. There are thousands of people here, not only observing, but in a big tent village that have been here overnight waiting for this spectacular event. And this thing is happening here in Xinjiang, in Xinjiang province, way out on the Gobi Desert. And we couldn't be doing this if we didn't have a great partner, and that's Xinjiang Television. That's given us our production services and our uplink services here. And to talk about this region in Xinjiang, I want to bring in Wendy Xu, who's a news anchor here for Xinjiang Television, who can talk a little bit about what's going on. I understand, Wendy, you've been over at the Solar Observing Plaza all afternoon. What's been happening over there?
Okay, there are over 10,000 people coming to this event in Yiwu, and as far as I know, there are 5,000 people in this observation plaza of Weizixia. In the last 2 days, we can say that the staff of the Solar Observation Plaza have finished the last touches of the decoration work, and there are also, among the observers to this event, there are both Chinese and foreign experts, scholars, and individual tourists. As far as I know, there are over 2,000 foreign tourists to this event. So that's part of the information that I can provide now.
That's really great. And you know, we were here a year ago preparing for this event, and there's absolutely nothing in this space, a very small village out here. It seems like people here have actually prepared a very big encampment for all of these tourists. Can you tell us anything about the work that's happened to make this possible out here near Yiwu?
Well, actually, I see the government takes this eclipse as a very big event. Actually, I think they have tried its best to provide good facilities and considered service. For instance, they have invested nearly 10 million yuan in constructing this solar observation plaza, as well as the supporting facilities. As for the accommodation for the tourists, they have also set up 200 tents with a reception capacity of 1,000 people. Also, they have tried their best to get the wet bamboo. They have tried to perfect the water and electricity supply system. As far as I know, the people here are quite satisfied with the services they provide now.
We certainly are ourselves. We've been taken care of very well in the encampment here, and I'm just amazed that they can handle this many people, an influx into a very small town that would normally have, I think, one hotel in Yiwu.
Yes, actually all this construction started just from this March. So that construction speed is amazing, I think.
That's absolutely incredible. Well, I've been coming here now to Xinjiang for a few of these production trips, and I find the whole region just fascinating. So we've asked you to prepare a videotape to show us some of the sounds of Xinjiang province, and hopefully let's roll that tape.
Xinjiang Uyghur Autonomous Region locates in the northwest China. Covering an area of 1.66 million square kilometers, it takes 1/6 of China's total land area. With a population of over 20 million, Xinjiang is home to 47 of China's ethnic groups, including Uyghur, Han, Kazakh, and Hui. People of ethnic minorities account for about 60.42% of Xinjiang's total population. Xinjiang was an important passage along the ancient Silk Road in the history, while at present it's China's bridgehead opening westward. Regarding the topography, 3 mountains, Mount Altai, Mount Tianshan, and Mount Kunlun, divide Xinjiang into north and south parts. Between the mountains are 2 basins, with Zhangge Basin in the north and Tarim Basin in the south. Xinjiang is endowed with unique and beautiful natural and human landscapes, such as snow mountains and glaciers, forestry and grasslands, desert oases, as well as historical and cultural relics on the ancient Silk Road and modern cities. Xinjiang enjoys long hours of sunshine and big temperature changes between day and night, which are quite suitable for the growth of melons and fruits. Therefore, it is honored as home to melons and fruits. Moreover, the region is the largest cotton production base in China, and its long staple cotton production volume ranks atop in China. With vast grassland, Xinjiang also sees thriving animal husbandry. The oases and pasture lands all show great vitality under the irrigation with snow-smelting water. Xinjiang boasts of abundant resources. Its coal reserve takes up 40.6% of the total in China, and the reserves of oil and natural gas both take over 30% of that in the whole country. As China carries out the Great West Development Strategy, Xinjiang takes the opportunity to quicken the transformation of advantageous resources and new type industrialization, and puts great efforts to develop the modern agriculture and featured industries. While China progresses in reform and opening up, the infrastructure construction of Xinjiang also improves a lot. All social undertakings including education, culture, science and technology, as well as medical treatment and public health, see booming development. People of different nationalities live together harmoniously and happily. Hami Prefecture, where the observation site for this total solar eclipse is situated, lies in East Xinjiang. Hami is a place with convenient traffic facilities and is plentiful in products. It is a major melon and fruit production base in Xinjiang and enjoys a reputation of the home to the well-known Hami melon. Balikun grassland and Yiwu River Valley, both to the north of Tian Shan Mountains, are important bases of animal husbandry. Moreover, the majestic mountain peaks, dense pine forest, vast grassland, and mysterious lake also make for attractive tourist resorts. In Hami, industry takes a leading position in its national economy, and its production value accounts for 70% of the total of industry and agriculture.
您现在收看的是新疆卫视。
So Wendy, one last question. What do you really like about living out here in this wonderful place?
Well, actually, there are a lot of things that I love about living in this region, because this place is really beautiful and resourceful. This is my hometown. I was born here and I grew up here, so I have very deep affection for this place. Well, I think what I love most about living in this place is the people, because the people here, although they are of different nationalities of China, but they're all very friendly, hospitable, and honest and industrious. That's why we can live in harmony and unity and peace. And I think that's one of the things that impresses the people, all the visitors from all over the world who have really visited this place themselves. So we welcome everybody from all over the world to come to this place, to travel around Xinjiang, because Xinjiang is a really wonderful place to travel. And we hope you can come here to discover the mystery and beauty in this part of northwest China.
Thanks a lot, Wendy. I know you're busy with broadcast and we'll let you go, but thanks a lot, and thanks for all the support from Xinjiang Television.
Thank you.
Let's cut to the solar eclipse again on the telescope. You see the moon has moved in a lot further. You can still see those prominences. And I think we should switch over to Paul. He's over with our telescope wrangler, Bill Dean, to talk about how we're getting these images.
Hi, Bill. You're our telescope and filter expert.
Yes.
So tell me, what's this telescope right here?
This is basically it's a zoom lens with a white light filter on it to safely block all of the light that would otherwise damage our camera or our eyes before totality.
So tell me about that filter on the front. What is that?
Well, it goes over the front of the telescope, much like you would use your eclipse shades.
I got those.
To safely observe the sun before totality. At totality, we'll remove the filter, and then we'll be able to see all of the lovely corona. So this will actually zoom out, so we see a wide field, and we'll see the inner and outer coronal streams.
Wow! So that's going to give us our human eye view of it.
Exactly.
Now, how about the? Oh, and let's take a look at the view through that telescope. So what sort of things will we see on this?
This we're seeing the moon cover the sun. We see the photosphere. This is basically it's the surface of the sun. If we had some active regions or sunspots, we might see some of those, but unfortunately today we're not going to see those.
Okay, and there's another telescope here, coupled to this one. What does this one do? It has this gorgeous red color in the front.
This is a telescope with a hydrogen alpha filter, which is a very narrow band interference filter which rejects all of the light, again for safety, but allows a very small portion of the spectrum in the red part of the spectrum. And in that line we can see the emission of hydrogen alpha. So we see these lovely prominence, these flame-like objects coming off of the limb, or perhaps on the disk we'll see plage, brighter areas, or even filaments, darker areas. But again, today we don't see those features.
Let's take a look through that one and see. So I believe this one shows the entire disk of the sun.
That's correct.
And we were seeing some of those prominences up there around 11 o'clock in this image. So we'll see some of those later.
We hope.
And okay, well that's going to give us the details of the solar system. In this hydrogen alpha, I guess that's a wavelength that hydrogen gives off.
Correct. When hydrogen is ionized, it gives off a photon at 656.28 nanometers. So it's very far in the red part of the spectrum.
So it looks red.
Very red.
Okay, let's move on to the next telescope. Now, this is a short, fat telescope. Tell me about that one.
This is, again, a regular telescope, but it's a little bit longer focal length. So we see it more as a telephoto lens, and so we'll see detail a little more close and personal. This also is safely filtered until totality. At this point, we'll see the same things as we see in the other telescope with the white light filter, the photosphere. But when we remove the filter at totality, we should have very nice views of the prominence.
Let's take a look at the view through that telescope. And I guess we're seeing a much enlarged portion, just one portion of the sun with
Correct.
the moon moving across it. Okay, so one last large telescope over here. So this is a beauty. It's huge. It also has that gorgeous red color on the front. What does this one do?
This is another hydrogen alpha telescope, but a longer focal length. So much like a telephoto lens, we'll really see up close and personal views of the prominence. And unfortunately, while at totality, we won't be able to see the prominence through this filter. With the white light, we'll be able to do that. We can also see, as with the smaller telescope, the chromospheric network details on the disk. We don't have a lot of those features to show you today, but we can try.
Let's take a look through this telescope. And I understand that you can actually control our view. So, you have this device you're holding up to show, and that device allows you to point to different portions of the sun.
That's right. We can move the telescope around and show you different features.
Let's do it. Bill's looking into his monitor, so he can actually, there's a camera on the end of each of these telescopes, and it's feeding into his monitor, so he can now control the telescope by watching. Now it's actually dimming down here.
Unfortunately, I can't control the clouds with this.
Yeah, a little tiny bit of cloud just drifted in, so it's getting very exciting here with between the clouds blocking the sun and the moon blocking the sun. Well, thank you very much. We'll look forward to seeing images from all these telescopes. Let's just take one image from one of the telescopes right now and see how we're doing.
My light reading meter isn't very accurate, and it's got about 100 foot candles with the cloud going in front of the sun. We think they're going to clear, though, and we're going to have a good image of the total solar eclipse when we get back to that. This meter also measures color, and when I was at the last eclipse in Turkey 2 years ago, I really found the color change very interesting as we got close to totality. We kind of think of maybe totality like being a sunset when the sun gets all red, but here, of course, the sun is getting covered when it's high up in the sky. It's more like a dark cloud passing over in front of the sun, and yet there's also an interesting color shift. So I'm going to see if I can measure some of the color shifting going on. And right now, already the sun, which is normally at about 6,000 degrees, the way we measure color, has actually come down to about 5,300 degrees at this time. And it might be a good time, since we're about 15 minutes from totality, to give the viewers a viewer's guide to the eclipse. What are they going to see when they see this wonderful event?
So as the moon moves to cover the sun, as it's doing now, and look at that beautiful arc there, even with a few clouds in it. The photosphere, the bright part of the sun that we normally see, like when you're watching the sun safely at sunset or looking through our safe solar viewing glasses, will be blocked by the moon. But the thing is, the moon has a rough edge, mountains and valleys, and some of that photosphere will shine through the valleys of the moon, and that makes a phenomena called Bailey's beads. So we have an image that shows that. So if I can show you the image. So there it is. The moon has almost blocked the sun in this image, and the light shining through the valleys on the moon makes a wonderful ring of beads. Now, also, accompanying Bailey's beads, when they finally go out, there's a red ring around the moon, and that red ring is a part of the solar atmosphere that we can never see when the photosphere is visible. It's called the chromosphere. And that chromosphere is the part of the sun. It's red to hot pink. It's a little bit dimmer and cooler than the photosphere, and the eclipse allows us to see that. Now, we can actually see in this image the peaks and valleys on the moon. This is an image of the edge of the moon, and it shows you that natural roughness. And even if we hadn't sent spacecraft to the moon, we could see that natural roughness by the Bailey's beads in the total solar eclipse. Well, finally, that chromosphere will be blocked, and then my favorite part of the eclipse will happen. The corona, this hot, million-degree Kelvin white gas, will reach out as white lines far out from the sun, and it's gorgeous. Also, the sun will go out. My eyes will adapt. It'll be night. We'll see the planet near the sun will be Mercury, A little bit further will be Venus, and just beyond that, the star Regulus. So we'll have night here for 2 minutes. Then at the end of the night, everything will be reversed. The chromosphere will appear on the other side of the sun, Baily's beads will appear, and then we'll be marching back to more regular view.
This is a spectacular image we're getting now from our live cameras of the eclipse. You can see the clouds are moving in. We hope they'll move away before we get to totality. It might be a good idea to start to talk a little bit about some of the solar physics that's going on in the sun.
So we have with us today Dr. Eric Christian, who's a NASA scientist, a heliophysicist, and he studies the sun and particles that come from the sun, including the solar wind and solar flares. Welcome, Eric.
Thank you, Paul.
So tell us about the sun.
Well, the story behind all the interesting things happening on the sun is the solar magnetic field. I like to think of the sun as a ball of rubber bands. And it's rotating, but there's something strange about the sun. Because it's a ball of plasma, of hot gas, it doesn't spin as a solid body the way the Earth does. And so the sun actually at the equator is spinning faster than it is at the poles. And this twists up those rubber bands and just continually twist them and twist them. Sometimes knots form in these rubber bands that are the magnetic field, and you get sunspots and active regions.
Let me show some images of those for you.
So here's an image from the NASA TRACE spacecraft of an active region. And what you're seeing is actually the hot gas tracing out the magnetic field of the sun. If you've ever done the experiment with a bar magnet, you know, where you put iron filings on it, you'll see that the iron filings actually trace out the magnetic field. That's exactly what we're seeing here. We're seeing the hot gas, and here's a nice movie from TRACE again, where you can see the gas flowing along these magnetic field lines and glowing. Pretty impressive. This is when the sun is really active, and you can see a whole bunch of active regions. So, twisting and tighter, and everyone knows what happens if you twist a rubber band too tight, it breaks. And the sun has to get rid of that twisting energy somehow, and it occasionally breaks. And there's two ways it does this. It can do this with solar flares. Oh, here we've got a great picture of a prominence. This is a big loop of magnetic field, again, with the hot gas flowing along it. But you can also get these snapping of the rubber bands, and that's a solar flare. Sometimes, to release the energy of the rubber bands getting tighter and tighter, you get a bubble of magnetic field and hot gas exploding out into space. And this is called a coronal mass ejection.
You have an image of that, too.
We have an image of that. This is from the SOHO spacecraft for NASA and the European Space Agency. And this is done with a fake total solar eclipse. We have a special telescope called a coronagraph out in space on SOHO where we block the light of the sun. You can see the dark disk in the center, and the white circle is where the sun would be. So here you can see the solar wind, the corona streaming out, and you see these occasional bubbles blasting out into space. Those are coronal mass ejections, and those are big explosions that move out into space.
Wow. Well, and the disk here, those in that image.
The dark disk is the occulting disk, what blocks the light of the sun, and the white disk is where the sun would be. So you can see it's blocking a lot more of the sun around the sun than the moon does.
So during a total solar eclipse, we can see closer to the sun than even in a spacecraft in space.
That's right. A total solar eclipse allows us to see really in close to the sun because the moon is such a perfect fit for the size of the sun. And that's really good because you see the area close to the sun where the solar wind is accelerated and where the corona gets so hot, and that's where all the action is.
Wow. Well, this is great for the sun, but what does it mean for us here on the Earth?
Well, the solar wind coming off the sun extends way past Earth, way past Pluto, billions of miles out, and this forms an atmosphere of the sun. You think of space being a vacuum, but there's gas out there, and that is the atmosphere we call the heliosphere of the sun. You can get storms in that atmosphere. These solar flares and coronal mass ejections actually cause storms to move out through space. And these storms can do a bunch of things. One of the most beautiful of them is that they cause the aurora, the northern and southern lights.
And we have an image of that right now.
It's just really amazing. The solar particles energize the Earth's magnetic field. Particles that are accelerated in that Earth magnetic field come in along the north and south pole magnetic field lines and glow when they hit the upper atmosphere in bright reds and greens and whites. It's really amazing to watch these ribbons moving high speed across the sky. It's really impressive.
That's beautiful, but what else does it mean?
Well, there's actually some dangerous aspects of these solar storms. They can cause power outages right here on Earth. They can actually fry the power grid on Earth. And there have been power outages caused by solar flares. They can also damage spacecraft that we've got. And although the Earth's magnetic field protects the astronauts most of the time when they're on the space station, if astronauts were on the way to the moon or to Mars and outside of the protective shield of the Earth's magnetic field, it could actually give them enough radiation to sicken them.
Wow. So now we were mentioning also that the corona is 1,000,000 degrees, and I always wondered, so how does the sun at 6,000 degrees heat this corona to 1,000,000 degrees? That seems hard.
The funny thing is, we don't know.
What?
And we've been studying the sun for a long time, and we just don't know. But it's total solar eclipses like this here on Earth that allow us to see, like I said, the region where all the action is happening close to the sun. And so you can actually, not only are solar eclipses absolutely gorgeous, we can actually do really good science with them.
That's great. So we have the beauty and the science together in a total solar eclipse.
Yep, perfect.
Well, right now, actually, a cloud has moved in and blocked our view of the sun, and it's 8 minutes to totality, and it's going to be a near thing about how that cloud moves. So we're on the edge of our seats right now with what's going to happen. So let me bring on here to Rob to check in these conditions with an eclipse.
A light meter. Well, you know, a light meter doesn't work very well when the cloud covers. I think my measurements have gotten a little bit distorted. Definitely got darker here. In fact, it's kind of interesting. With this cloud cover, I'm down to 100 foot candles.
Wow.
That was 2,000 bright sun, 100 foot candles now. And we expect there's a little hole in the sky. I think we're actually going to make it, Paul.
Oh, there is a hole. I hope so.
It's pretty spectacular. We could heard a lot of booing in the audience out here because they're really wishing these clouds to go away. There are also some interesting effects. Some of the cloud cover actually will start to disappear. It starts to get colder out here when the sun is getting more and more occluded by the moon.
It definitely feels cooler to me.
Yeah, it does to me too. I'm starting to feel the breeze. What's your thermometer say?
Oh, it's down to 90 degrees from 101, so we're down 10 degrees already.
That's actually good. We've been really baking out here in the desert out here. So actually what we're going to do is probably switch back and forth between when we get a clear field view of the telescope views. Right now they're completely blocked out, but I think in about 30 seconds looks like we may be back into business here. The audience is really starting to get excited out here. Everyone's got their telescopes up, ready to watch. People are stretched out over this plain for miles with setups. It's kind of incredible. I've seen more buses bring people in with telescopes than I've ever seen in my life.
In fact, the thickness of the clouds right now, I'm not sure if we can get an image of the sun up there in the sky, but you can see it through the clouds as just thin arc of light as the moon races to cover the last bit of the sun.
It's definitely getting darker here, and it feels a little darker than just cloud cover, I'd have to say.
Oh, it does. Well, there's only a few percent, I think, of the sun left, and that really is blocking it out. It's actually interesting that the clouds are acting as my safety glasses to watch the sun. You should never look at the sun, even in a partial solar eclipse, without some form of protection for your eyes.
Now might be a good time to remind folks that when we get to totality, we're going to take the filter off the telescope that's going to view totality. You may see a little bit of shaking, but then the image should stabilize really well at that point.
So half the crowd in the distance, I can see that they're in sunlight, and they just sent up a cheer because they can see the sun now. Oh, here we have a diamond ring coming out on the sun, a really bright diamond ring. And,
so let's switch to the telescope views if we can.
Okay.
All right, telescopes still aren't picking it up. Still too much of a cloud cover blocking things. It's interesting, the eye can actually see something a little better.
Yep, there's still a bit of the sun shining around the edge of the moon, so we're not to totality yet. A little ways to go. Maybe that diamond ring was being caused by the clouds.
I think so. I think it was a little bit off.
I was a little faked out there.
Actually, if you look through a viewer, maybe we can see what's happening.
Let's take a look. Oh yeah, so indeed there's still an arc of the sun shining around the moon. Not to totality yet. Creeping on toward totality, watching how the cloud is moving. It's right on the edge. Oh, there we go. So here we go. You can see on the telescope the thin clouds that are in the way.
It's a fuzzy image, but we'll get it sharp in a moment here.
Yep.
There it's sharpening up.
Yeah, there we have that really bright part of the sun showing. And oh, it's really getting dark fast now. The edge of the cloud, boy, this is going to be really close. We've got a cloud edge coming in as the moon moves over. We still have oh, this is going to be really close.
Really close one. I know, about a minute or so to go to totality. It's hard to focus the telescope when we got these clouds passing in front.
Yep, so there's still a bit of the sun showing, playing tag here with the cloud bottom. Come on, clouds, move out of our way.
2 minutes to totality, so it's actually brighter than normal.
Yay, it's moving clear of the cloud now, so maybe our folks can focus the telescopes.
Part of the issue is we're on a telescope that's actually got very, very precise optics so we can see totality. So it's actually a little brighter than normal, so the telescope is kind of getting blown out a little bit.
Oh, there we go. And that's the last little rim of the sun with one of our hydrogen alpha telescopes, greatly in focus. And boy, that's quite an arc there. Oh, wow. We've moved free. The cloud is free. Now, if we can get that white light telescope focused in. Yeah, I can looking by eye, I can see that last little edge.
It's still actually early to use the unaided white light telescope, so we'll get to that as soon as we get to totality. It's set to really see all of the effects, like the corona and everything, at the moment of maximum darkness.
So it's just ever so slowly moving, but I think we're clear of that cloud, which is quite exciting. Boy, that was something.
Color out here is getting really dark. It's kind of the spooky color of light. We know the cloud isn't in front of the sun now, but it's actually dark out here.
Yeah, it really feels strange. I wonder what the light color is, the color temperature is right now.
Let me check here. Okay. I can still read my meter, but barely.
There it is in white light, in focus. We got that edge of the sun. Boy, this is...
We're down to about 40 foot candles.
Okay, just a tiny edge of the sun showing.
The color temperature is about 56 degrees.
Oh, it's really dark.
5,600 degrees.
The crowd is actually being very excited, dancing around. Okay, here it comes. We have that diamond ring, a really nice diamond ring. And I see Mercury and Venus. The corona is reaching out away from the sun. Oh, it's really gorgeous. There are streamers coming out from the sun. We have like maybe 4 major streamers coming out like a spider out in the sky. And the amazing thing is that we have this dark circle in the middle of the sky. And around us, it's like sunset all the way around us in this circle. Oh, here we go. We've got the corona. You can see on the right side of our image some of the lines of the magnetic field reaching out from around the sun in that corona. So, oh, there it is. There's some of the lines in the magnetic field in the corona. Oh, there's some bright places there around the rim. Oh, look at that. There's the prominence, the bright prominence in the upper right corner of this. Oh, my eyes are adapting now, and I can see more detail in that corona. Although I can't see that prominence that the telescope is picking up.
It's amazing. It just seems like there's a black hole in the sky where the moon is covering the sun, almost like someone drilled a hole into the sky.
And I see it's actually beginning to brighten up towards the west.
What's amazing is we have a 360-degree sunset. The sky is actually like sunset 360 degrees around us. I've never seen anything quite like that.
Well, there we have some detail in the telescopes. You can see the magnetic field of the sun guiding that corona out into space. We're panning all the way around to get you a close-up of the details here. It's just this amazing thing where magnetism becomes visible in the sky. Ah, there it is. Here it comes. Here it comes. There's the diamond ring again. Time to put the glasses back on. Now there's this amazing light in the world around us. That was really exciting. And here we're showing in the hydrogen alpha this edge of the sun, and perhaps in the visible here, we see the edge of the sun again getting larger. I can't watch now with my naked eye. I have to use the viewer. The crowd around us is cheering the return of the sun, as I'm cheering the return of the sun, although I sure did love that view of the corona during totality. So here, the light's building back fast. I can see around me quite easily. I'm sure glad that cloud moved away.
I really lucked out on this one, Paul.
Oh boy, that was like blocked until a few minutes before totality. Here we have the arc of the sun is growing. I'm looking for the prominence that was here earlier, but I don't see it. It's actually interesting hearing the waves of cheering going on in the audience out in the desert.
It definitely got chilly out here, too. It got pretty cold.
Oh, yeah. Oh, in fact, let me check my thermometer. So my thermometer is down to 89 degrees, so a little more than 10 degrees Fahrenheit cooling.
The moon is slowly pulling away from the centered on the sun.
So we'll come back to the part. We're now in the partial phases. It'll be another hour before it clears. That's a wonderful crescent arc of the sun. I just love that.
I just love this part of the eclipse. I mean, the eclipse is fantastic, but just this edge, too, that you normally can't see. Right. That crescent is just beautiful.
So, in fact, here's the crescent in white light.
So, Paul, I mean, it's interesting. What did we notice this time in the eclipse? What really impressed you?
Well, I really like that more rectangular, boxy shape of the corona. I think the predictions were for 3 streamers coming out of the sun, yet my eye made out maybe a 4th streamer, making a beautiful box. It's very organized corona this time, and I'll ask Eric in a little bit about why that might be so organized. Also, with this 30-mile ring of the umbra on the surface of the Earth, the dark shadow, I could look around the horizon. It was a sunset 360 degrees around.
I know, that's really impressed me. I've never been on such a flat plane where you can see for miles around, and to see a 360-degree sunset is really incredible. I'm sure we can't really show that with the cameras we've got. We'll have to get some photographs of it and post them on our website. You can see here the crowd, the sun is coming back. The crowd is still very excited, exuberant. Everyone who's been around the telescopes is really excited. They hope they got the photos that they're asking for. They'll know when they get checked later. Yeah,
I got my eye full, so that was good.
Maybe now's a good time to bring on Eric to talk a little bit more about the corona.
Right. So, Eric, tell us about that corona we were seeing.
Well, that was really neat. I mean, every eclipse has a different corona, and this one was a sort of classic simple magnetic field corona. When the sun is more active, which it is every 11 years, you see a very contorted corona. But right now we're in the solar quiet period, which is why there are no sunspots, which is why we don't have very many solar flares. And so we see a very organized corona. We've got a couple pictures from historical solar eclipses that we'll show you, so you can see the differences from eclipse to eclipse. Here's one where the sun is in an active period. You see streamers going every which way. This is pretty neat. This is when the sun's magnetic field is really twisted up.
Sun with a bad hair day.
Yep. And the next one is also the same sort of thing. Very contorted, very twisted.
Wow.
Wow, look at this. Just streamers going every way.
Like the previous eclipses I've seen, actually.
Yeah. And so let's go to the third one. Here you see, with a little bit of the diamond ring, something more similar to what we saw today.
Yeah, that was very much like what we were seeing.
This is the solar corona when the sun is quiet. So this is sort of classic. This is the sun's magnetic field looks very much like a dipole, like your bar magnet, and so you get the polar plumes coming out and a very organized equatorial coronal structure.
Well, this was your first eclipse as an adult. How do you feel about it?
It was fantastic. It was really, I mean, it got colder, just the cloud, sitting there, come on, clouds, go, go. but it's really kind of funny because I noticed something that I really didn't expect, which was that even when it got really dark, just before totality, the shadows were really sharp. And I wasn't expecting that. You know, normally when things are dim, you don't get strong shadows. It sort of looked like a low-cost movie where they film it at day and put a filter on to make it look like it's night. And that really sort of surprised me how sharp the shadows were.
Wow, that's good. So it's nice to be a good observer of nature when you're seeing an eclipse.
This was a lot of fun.
Well, yay, Eric. Thank you very much. So, Rob.
Well, yep. So another eclipse.
Another eclipse.
That was just fantastic. 8 for
Just
you.
barely.
I know. The people we really got a lucky success here at the end. That hole just appeared just right in the clouds.
Right.
So I just think it's been a fantastic event. Thanks for providing all the commentary on the what we saw in the telescopes.
Great.
And
it was fun.
Next time.
We'll
see you next time.
Shanghai.
Right, Shanghai. That's right. Next time. And actually, as things sort of return back to normal, it's really kind of bizarre because all of a sudden it's getting pretty much just the same out here in the desert. And one of the things I find really strange about eclipses is that this amazing event can happen here, and then a few minutes later, it's almost like it never occurred. It was like a dream. The people are still excited and exuberant about what's happening here. The next eclipse, for those of you who want to see it, is going to be July 22nd, 2009. It's going to be starting in India, passing across through southern China, and moving out to the Pacific. And I suggest you get your hotel reservations now because I know all the people around here are already booking their hotel and flights to go and see it. If you want to see more about the eclipse or see a replay of this program, visit our website, www.exploratorium.edu/eclipse. Now, it takes a lot to put together a program like this. You'll see the credits of all the people that helped us at the end of the show, but I want to acknowledge a few people that really supported us in this endeavor. One is our friends from Xinjiang Television, who gave us this marvelous ability to provide this program to you out here in the field. The folks at the Urumqi National Observatory really helped us understand what was going on in terms of space science here in this area and have been really helpful in letting us do this work. The National Science Foundation Beijing office really helped us get connected with the right people here in China to make this happen. And of course, our friends at NASA have always been supportive about this program and all of our funders that have made this project really a success. We're going to leave you with some images of the moon slowly receding from the sun. And probably the things that really impressed me the most about this eclipse were three things. One, the regularity of our relationship between the sun and the earth is really fantastic. You know, we know about day and night, we know about the seasons, but we can predict these eclipses. They happen with regularity. In some sense, that's actually reassuring that the world is actually, in some ways, working in a way that we can understand. But also the fact that all these people were here from all over the world to experience this event reminds me that people really like to be involved in awe-inspiring events like this. We're all the same all over the world, and this event really shows it with its international flavor. And finally, on a more sobering note, during the eclipse itself, you really get a sense for how thin our atmosphere is here, how, in a sense, how this thin atmosphere is protecting us from space. We are all stewards of the world, and we really need to protect it. So here on the edge of the Gobi Desert, in the shadow of these beautiful mountains, on this vast plain, it's Rob Semper from the Exploratorium saying goodbye and good luck.
快把从进到出全拍完了。啊？
Yes, please. And at your convenience. Oh. 没有，他到8点多了。 哇塞，你们看一个，人比赛越混越滑。
好的，节目最后呢，我们将会以一首《我的太阳》来结束今天的直播节目。